We're going to be presenting our work on making and testing new polymers for architectural coatings. So architectural coatings include paints, primers, and stains. And we're trying to improve this technology because if we can improve the technology, we can decrease the cost of materials used, we can decrease the environmental impact of paints, and potentially improve paint technologies.
I've been doing what's called viscoelastic testing using this rheometer guy right here. The rheometer is used to study the rheology of a polymer, which is the flow behavior. Specifically, the kind of stuff I've been testing is the viscoelasticity of these polymer solutions. Viscoelasticity is like the time or shear dependent response of a material to stress. Like if you think about silly putty, if you just kind of stretch it, it'll flow. But if you go like this, it snaps. So like all polymers have both a viscous and an elastic component to them. And we want to know which one's the most dominant. And we want to know when and if they're going to switch behavior, because it's really important when you apply that to paints and apply it to paint performance and processing. You don't really want elastic behavior. You don't want to be trying to spray paint and it gets all clogged up because the shear is so high that it's starting to have that solid-like behavior. So it's really important to have the right rheology in a paint formulation.
So what I mainly do is polymer synthesis. My team and I are really the ones creating polymers, and we use these to test on different pieces of equipment and instruments that you see around here. And that's because what I mainly really focused on was mainly the chemistry and how we wanted to formulate our polymers for testing.
And being able to do these kinds of tests, we can learn a lot more information than just studying the viscosity of the material alone. So by doing the viscoelastic work, in addition to all of the other characterization work we're doing, we can kind of create a library of the different properties of each of these polymers, and we can use that information to decide what would be best for a particular application, or something that's working really well but isn't quite where we want it. We can be like, oh, well, we can synthesize something that's a little bit different and it might have better properties, but you need somewhere to jump off from. And having all of this information that we're collecting with the different characterization methods, that helps us make better decisions about where we want to go.
The best part about working with undergraduate researchers is they come in, they don't have experience in the lab yet, they don't have preconceived notions, and so we can try new things. They have new ideas, they're creative, they're enthusiastic, and so they keep coming in, we keep trying things, and they add their perspective and new ideas, and it allows the research to evolve and go in directions that maybe we didn't expect, but are exciting nonetheless.
I've been doing research for a year now, and I've really liked it. I think it's a lot of fun.